everyone, I welcome you to another episode of our secondary school mathematics course. Now, at this secondary school level, in this episode and on this bright day, we will be doing sets. Now, this will be the first part of two parts I will be doing on sets. So make sure you watch the second part after this part. Now, this first part, we'll be talking about the introduction into sets. So what are sets? A set can simply be seen and be defined as that collection, that organization, that place you belong. Like a church is a set of worshippers. Like a school is a set of students, right? A staff room is a set of teachers. Yes. What else? The solar system is a set of stars, obviously. Now, but that's not very obvious that either. Now, moving on, a set from what I've given so far, I've given obvious, not so obvious, but I've given practical examples of sets. Now, a set is basically just a group of things, just a collection of things. For example, those your friends. Yeah, those people you move around with, those people you talk to, those people you chat with, those people you enjoy being in their company. That is a set of people, and you are part of that set, and you are a member of that set. A set is basically a collection of things. It could be persons, it could be things, it could be items, it could be who knows, whatever. So a set is just a collection of things, and that set, the number of things in that set is basically the cardinality of the set. Now, the cardinality of a set is the number of elements or things in that set. For example, if I have 4 friends and we all move together, now we form a set, and the cardinality of our set is 5 because we are 4 friends including me. So that is the cardinality of the set. Now, in mathematics, we don't bother about friends. No. So what we bother about is the numbers. So in mathematics, we define set in terms of collection of numbers, or basically a collection of things that have mathematical properties. So for example, we could call a mathematical set a set of items that are used for drawing. So that is known as the definition of a set. It can be defined as the set of items for drawing. So I could call it items for drawing. Or rather, I could basically call it a mathematical set. So what's obvious here is that there are 2 different ways of naming and understanding your set. You can name your set based on listing all its elements. So if I say items for drawing, I could keep listing like your protractor, your set square, your compass, your whatever, blah blah blah. Now, that is one way of defining a set. Another way of defining a set is by just giving a property. Now, this property is a mathematical set. Basically, all those instruments that are used in mathematical sets. So it's the set of mathematical instruments. So there are 2 ways of listing your elements, of describing and explaining what a set is. You can explain number 1 by listing what it contains, or you can explain by just giving us a general term. For example, in those group of your friends, I could call them basically just jolly friends. So jolly friends is just a general term that describes them. Or if I wanted to describe the set in another form, I could just say the set of Philip, Thompson, James, so on and so forth. So I've condescended to the level of listing out the name of every person in the set, and that is the 2 different ways of understanding your set. Now, enough of definitions of set. Let's go into a little bit more intricate detail. Now, a set, types of set. Let's identify types of set. They are equal sets. Now, in mathematics, let's move away from our set of people, set of mathematical sets, set of sets. So now, in mathematics specifically, and in your exams, you'll be dealing with sets of numbers or sets of alphabets. Now, for example, let's A. Now, your set will often have a name in mathematics. A will be the set, and then every element of your set is contained within 2 curly brackets. So that would be this. So just like the curly brackets that are used in AppleScript coding. So when you are programming, those curly brackets are used in JavaScript, AppleScript, so on and so forth. So that is the kind of brackets that will precede your element. Now if this A is a set of let's say A, comma B, comma C. Now this set A contains 3 elements, and so the cardinality of set A will be what? 3. So that would be, we'll represent it as n open bracket A close bracket. That would be 3. So this is the symbol for representing the cardinality of a set. Now these brackets are not curly brackets. These are just normal curved brackets. But this set itself is explained in terms of your curly brackets. So don't forget that. Very important. Now moving on. This set is ABC. If we have another set B of B, C, A. Now we could describe this set of ABC as, and the set of BCA, we could say A is what? Equals to B. Why? Because they contain the same element. So what's obvious? What's obvious here is that now it doesn't matter the order of the terms. So what matters is the elements that are in the term. And it doesn't even matter whether they are repeated. For example, if I change this to B, BC, AC. Now, as long as C is repeated, it is still considered the same element. So it doesn't need to count. So this B and A, they are equal sets in that they contain the same elements. So this contains elements A, B, and C. This also contains elements B, C, and A, but just in a reorganized form, and the repetition does not matter. Now, we have cardinality of a set. Now, but if we are talking about the cardinality of a set, A has a cardinality of 3 and B has a cardinality of 4. That's the number of elements in B will be 4. Because it has 4 distinguishable elements. But then A, B, and C, they are just like equal sets. Now moving on, another type of set you can encounter in mathematics is the universal set. So universal set is like a jack of all trades. It contains every other set you can consider in your question. Now, for example, if we're talking about the set of human beings, like that's a universal set, or rather, I'm even being lenient. Let's talk about the set of all living things. So that is like whatever flies, whatever is in water, whatever breathes air, whatever breathes carbon dioxide, or whatever. So everything that has life, you will be in that set. For example, let's represent it as a rectangle. You will often see it represented as this, as a universal set. So this rectangle represents a universal set, and every other thing, any other subset of that universal set will be inside it. Now, any set that is inside a set is called a subset, and that set that contains another set is called a superset. So a set inside another set is a subset, and a set that contains another set is a superset. So another way you can represent this is, if this is universal set and then you have a set A in universal sets. For A, this is a set A that is in the universal set. For example, let's say A is a set of human beings. A is a set of humans. Like me and you, we are humans, right? Are you sure? Are you a human being? Okay, I can't verify that. Now, the next set U is universal set, UNIV, and that universal set is a set of all living things. So you can see that this universal set of living things contains the set of human beings. Now I will explain further in that every area of this universal set that is not in this set is called the complement of that set. Complement. Now it is denoted by A with a little bit of a stroke on top. So that is A complement, and that is the set of all living organisms that are not human beings. So we can just call it not human. But they are living organisms because they are in the set of living organisms, which is the universal set. So now, in sets, these are the basic regions you need to understand as a new student or whatever. Or maybe you are just someone who wants to revise and continue understanding sets. So whatever, you still need to understand this concept of universal set, of subset, that is the set in another set, and superset, which is the set that contains other sets, and then the complement of a set. Those are the basic terminologies. So even if you are dealing with 2 subsets, 2 intersections, and 3 sets and 3 subsets, who knows, you might be dealing with even more than that. So no matter what number of set, just understand the concept of what is in the set and what is outside the set. What is in the set is the set itself, and what is outside the set is the complement of the set. Then the set that contains every other set in a particular consideration is the universal set. So I guess I've driven home a point. Now let's move on to the empty or null set. Now an empty or null set is a set that contains no elements. And what am I saying is that that set is just empty, that just like an empty house. And it's denoted like, let's call it set E. Yeah, E for empty. So set E is basically in curly bracket like this, and those curly brackets, they have nothing in them, so it's just an ordinary curly bracket. You can also represent it as a circle with a just like theta. So it's just like theta. So, and this is another way of representing an empty set. You can use any of this. Or rather, let's call it phi. It looks like phi. So it doesn't matter, but any circle that has a stroke through it is also another representation of an empty set. But in order for you not to avoid complications and misunderstandings, you can just make use of the first method. Just represent your set as two curly brackets with nothing within them. So that is how an empty set is, and it's kind of like a waste of effort. Empty. Now moving on, we have the finite set, and then your finite set is a set that you can be able to list all the elements. For example, A is a finite set because it contains 3 elements. I can list that without any effort. A, B, C, no effort. Now, but an infinite set is a set that contains elements that can never be exhausted. For example, the set of positive numbers. You might think that's exhaustible. No. So positive numbers range from 1 to infinity, and nobody knows what infinity is. So we just keep discovering new quadrillion, billion, zillion. So those numbers, they have no end. That is infinite set. Now, but infinite set is a set that you can be able to list the elements, but infinite set cannot list all the elements. Next, moving on, we have we've talked about subsets, we've talked about supersets, we've talked about. So lastly, let's talk about the disjoint set. Now, a disjoint set is, you can say two sets are disjoint if they do not have any similar element. For example, this set A and set B, they are similar, right? But if I give another pair of sets, set C, of which contains elements A and B, and I give set D, which contains elements elements E and F. Now, if there's no elements that is in both of these sets, or if there's nothing common about the elements of this set, you can call it a disjoint set because there are no elements that are shared by each of the sets. Now, this set C contains elements A and B. Set D contains E and F. None of their elements are similar, so that is a disjoint set. Now, moving on, let's try an example in sets. So, given an example here. So, let's work it out. So first of all, we have if A is equal to PQRS, B is equal to TURQ, C is equal to P, Q, R, Q, S, Q, cubes. Now then D is T, R, Q, U. Decide whether each of the following is true or false. So let's list the sets out. We have set A, P, Q, R, S. A is set P, Q, R, S. B is the set C, U, R, Q. Then C is the set P, Q, R, Q. Oh, Q, R, Q, S, Q, S, Q. I'm not speaking Spanish. So And lastly, we have our set D. D is the set of T, U, good. Sorry, T, R, Q, U. T, R, Q, U. Sounds funny. So now moving on, it said we have to decide whether each of the following is true or false. A is set A equals to set B. So look at the set. Is set A equals to set B? That's obvious. No. Because why? Because a set is equal only if their elements, all their elements are equal to each other. So for example, this contains P, but there's no sign of P here. P is absent. This contains T, but there's no sign of T here, so they are not equal. So a set are only equal if their elements are similar. That's false. Number 2, number of A is equal to number of B. So that's cardinality of A is equal to the cardinality of B. Is it true? Check the board. Is that true? So what is the cardinality? You need to ask yourself that first of all. Now cardinality is basically the number of elements in a set, right? So the cardinality of set A is 4 and the cardinality of set B is 4. So that means if the cardinality of set A is equal to the cardinality of set B, that means n open bracket A will be equal to n open bracket B. So that is true. They have the same cardinality because each of them has 4 elements each. That's true. Moving on, we have C, A is equal to D. So is set A equals to set D? A is PQRS and D is TRQU. So that will be false. A cannot be D. Then we have question D. The number of elements in A is equal to the number of elements in D. So is that true? And number of elements in A is equal to the number of elements in D. So that is true because each of them has 4 elements. So number of elements doesn't necessarily mean that they are the same element. So it's just trying to ask you that if A has 4 elements and D also has 4 elements, regardless of whether the elements are similar or not, their cardinality is equal. So note that. Now moving on to question E, we have U. U is an element of C. So is there any element like U in C? So C is P, Q, R, Q, S, Q. There's no U. So that is false. There's no U. So moving on, we have question F. So question F is asking is T is not an element of D. Now I forgot to add this, but whenever you have an element of a set, it is denoted as this. If P is an element of C, we say P is E, we make use of the E and then the set. So but if R is not an element, we simply write R element we'll cross the element of C. So that is how you represent that something is an element of a set and something is not an element of a set. Now, so for that question F, we have that is false because T is definitely an element of D. That's T is in set D. Now we have question D is B is set B equals to set D. So set B is TURQ and set D is TRQU. So it's obviously true, they are similar, they are the same because this D is just a rearrangement of the elements in B, so that is similar. So the answer is true. Now question H is B equals to B is not equal to C. They're asking B is not equal to C, true or false? So B is not equal to C, true or false? That is B is TURQ and C is PQRQ. Come on, so many differences. That's true. B is not equal to C, true. So that will be true. Then we have question I. The number of elements in C is 6. Is that true? Number of elements in C is 6. Now I love this question. Number of elements in C is P, Q, R, Q, S, Q. Can you spot the bias? Now in literal terms you would say it's 6 terms, it's 6 elements, right? But one time you have an element that is repeated in a set, it is not counted the second time. So in this C of set P, Q, R, Q, we won't count Q again. So and then this Q again, we won't count it. So that means P element set C contains only P, Q, R, and S. So set C is set of P, Q, R, and S, and it has a cardinality of n of 4 and not 6. So when you repeat elements in a set, do not count them the second time. Now moving on, we have the last question for this example. Is set A equal to set C? Look at set A. Is it equal to set C? So you should try that. Is it equal to set C? You might want to pause the video to. Okay, now set A is equal to set C, even though set C contains a repetition of certain elements of set A, but those repetitions do not matter. So that means anytime you have an element, you are looking at the elements and not the number of times they are repeated. So set A is PQRS and set C is PQRQSQ. So those Q's that are repeated do not matter, and set C is still the same as set A. Now we've gone this far, and let's give us a bonus idea on set, and this will be the last idea on which our next part on set, the second part of set, will be based. And the next part of set will be based on union and intersection. So let me explain what a union is. A union is basically the coming together of two things, right? So and a union in set is that middle set that contains the two sets, the two first sets. For example, if we have a set A and this set A contains PQRS, R, S, and then we have set E, not an empty set now, Now set E is P, Q, Y, and Z. Now we are looking for the union of this set. The union of the set is a new set that contains only the elements. The union of two sets is a new set that contains all the elements in the first two sets. So what that means is that you are going to write every element you can see in the first two sets without repeating elements. So the union, you write elements of A and you write the elements of E together in the new set. So let the union set be U. So the union set will become the set of P, Q, R, S. So now we are encountering P again in set E. We won't repeat that. So we won't repeat P, we won't repeat Q, we'll just move straight to Y and Z. So the union of this set is P, Q, R, S, Y, Z. Now the intersection of a set of two sets is a third set that contains only the elements that are in both of the first two sets. So the intersection is a set that contains only those elements that can be found in the two. Now what elements can be found in both A and E? You can see that P is in A and P is also in E. You can see that Q is in A and Q is also in E. So this element consists in the intersection set I will be equal to the set of P, Q only. So we discard the rest because they are not the intersection. They will not be elements of the intersection set. So thank you for watching this far, and watch out for the second episode of set. I hope you enjoyed this video. Don't forget to like, to share, and to subscribe.